today's class we will see how to calculate the ultimate or the net safe bearing capacity of a given soil for this given problem. Okay, so in this problem it is written as that when a vertical face excavation was made in a deposit of a clay, it failed at a depth of 2.8 meter of excavation. Okay, so find the shear strength parameters of the soil if its bulk density is 17 kN per meter cube. In this deposit at some other location, a plate load test was conducted with 30 centimeter square plate placed at a depth of 1 meter below the ground level. Okay, the ultimate load was 13.5 kN. Water table was at a depth of 4 meter below the ground level. Calculate net safe bearing capacity for a 1.5 meter wide strip footing to be founded at a depth of 1.5 meter in this soil. Takes factor of safety as 3 and use bearing capacity theory. Tarasaki is bearing capacity theory. So what we need to calculate the net safe bearing capacity. Okay, so we need to find the net safe. So first we have to find the ultimate bearing capacity of soil QU. From that we will find Q net ultimate. From that we can find the Q net safe bearing capacity, and after that from that we can find the Q safe. So we have been asked to find this thing. Q safe is nothing but Q net safe bearing capacity plus gamma df, the density of the soil multiplied by depth of foundation. Okay. So if in the problem they are asking the net safe bearing capacity, so they don't want Q safe, they want this thing, net safe bearing capacity. So Q net ultimate can be calculated as QU minus gamma df, and Q net safe is calculated as QU minus gamma df, that is Q net ultimate divided by factor of safety FOS. So exactly in the problem they ask this thing to calculate. So for calculating the Q net safe, what is the, we need to calculate Q ultimate. Okay, that is QU net ultimate bearing capacity of soil. So for a strip footing, since in the problem it is written as a strip footing, okay, where is it in the strata normal? Sorry, not this one. Vector test strip footing is given. So for strip footing QU, that is ultimate bearing capacity, is given as CNC. QU is equal to CNC plus gamma df NQ plus 0.5 gamma B and gamma. Okay, remember this ultimate bearing capacity is formalized for strip footing. CNC gamma df NQ plus 0.5 gamma B and gamma. For square footing, it is given as QU is given as 1.3 times CNC, 1.3 times CNC plus gamma df NQ plus 0.4 gamma B strip footing, ultimate Dalzakis ultimate bearing capacity is given as CNC gamma d NQ plus 0.5 gamma b and gamma. For square footing, ultimate bearing capacity is given as 1.3 CNC gamma d NQ plus 0.4 gamma b and gamma. Okay, so this is the values we are given. Okay, so in this case we have to find QU for strip footing. Okay, so for that we need NC, C, gamma, depth of foundation, breadth of foundation and everything else. So what in the problem has given us? So what in the problem we have been given? So it says that it's a clay deposits. Okay, and fills at the depth of 2.8 meter of excavation. Okay, and also its bulk density is given, means gamma is given, so it's not an issue. So and since water level is far below, since we don't have to worry. Look, in this was at some location plate load test was conducted at 30 centimeter square feet, depth of 1 meter below the ground level. The ultimate load was 13.5 kN. Water table as was at a depth of 4 meter below the ground level. Okay, and now we have to calculate safe bearing capacity for 1.5 meter strip at a depth of 1.5 meter. So depth of foundation is given here. This is 1.5 meters, and the water level is at a depth of 4 meter. Since water level is too much below, that is below the depth of foundation, hence it will not affect any loading parameter for the foundation. Okay, so we can directly take this density as the bulk density of the soil, that is gamma. We can directly consider this thing. Okay, so what we need to find in this case? So it has been informed in this problem that it is a clay deposit. For clay deposit, for clay we always know that its phi is equal to 0. As soon as phi is equal to 0, you know that NC will be equal to what? We have to know this thing. For phi is equal to NC is 5.7, NQ will be equal to 0, and NQ will be equal to 1, and N gamma will be equal to 0. Okay, so for phi is equal to 0 for clay, NC is always, if it is given in the problem then it's fine, but if most of the time in the problem it's not given, so we have to know that for clay soil, that is angle of internal friction phi is 0, NC is 5.7, NQ 1, and gamma is 0. So we directly get this thing from knowing that the soil is of clay. Okay, next we got NC, NQ, N gamma. We have gamma also. So we have this width of footing also. Width of footing is given as 1.5 meters. It is told in the problem. Gamma we know. Depth of foundation is also 1.5 meters. So what's remaining? The NC also we know. So remaining is C. What is the cohesion of the soil? How will you calculate the cohesion of the soil in this numerical? This is the main problem of the soil. How you calculate the cohesion? So how you calculate? So first thing first, the problem says that it filled at a depth of 2.8 meter of excavation. So whenever a clay soil is excavated, there is a certain safe height up to which we can excavate, that is considered as a HC. As you can see, the clay soil can be excavated up to a certain height without vertically without giving any lateral support. Okay, without giving any lateral support, that height is considered as critical height, that is SC. So the clay soil which can be excavated up to a depth of up to a critical height, clay soil can be excavated up to a depth of critical height HC without any horizontal or lateral support. Okay, and that HC is nothing but twice ZC. And now what is ZC? ZC is this much. ZC is this much. ZC is the depth of tension failure. Depth of tension. Here the particular, due to certain its own weight of the soil or due to surcharge, there is a tension failure plane occurs when you excavate a clay soil up to a certain height from the ground level. This is the ground level. Tension failure occurs. Okay, and after that means the soil is in tension in this part. Okay, and that height up to which the tension failure occurs is considered as a ZC, whereas HC is the critical height up to which the soil can be excavated without giving any lateral support, and that HC is nothing but equal to twice the ZC or twice the depth of tension failure. Okay, so this is the stress variation diagram for a for a clay sample, for a clay soil. Okay, so up to a certain height ZC, the soil is in tension, and after that it goes into compression positive. Okay, so ZC, that is height up to which the tension cracks occur, ZC is given as equal to twice C by gamma divided by under root KA. Okay, twice C by gamma. So hence HC, that is critical height up to excavation can be carried out, is nothing but twice of ZC is nothing but 4 times C by gamma under root of KA. 4 times C of gamma under root of KA. Okay, so ZC, so HC is nothing but twice of ZC, safe height, or you can also consider as a safe height up to which the soil, clay soil, can be excavated without giving any lateral support, is nothing but 4 times C, 4 times C by gamma under root Ka, 4 times C divided by unit weight of soil under root of Ka. Okay, this Ka is nothing but equal to 1 by Kp, 1 by Kp, and Kp is written as Kp is nothing but 1 by tan square 45 degree plus pi by 2. Kp is nothing but equal to 1 by tan square 45 degree plus pi by 2. So under root K becomes 1 by under root of tan square 45 degree plus pi by 2. Okay, and that turns out to be tan square 45 degree, and it goes on and becomes tan 45 degree plus pi by 2. Okay, so in this case we can write HC equal to 4C by gamma multiplied by tan, not tan square, tan 45 degree plus 5 by 2. So in the problem, what we have given in the second statement, it is given that it fails at a depth of 2.8 meter. So this 2.8 meter is nothing but HC. This 2.8 meter is nothing but the HC, and from this formula we can calculate the quotient value. In this case the phi is 0, hence we can find the quotient value. So here we can write 2.8 is equal to 4C. What is gamma? Bulk density, which is given as 17 in the problem, tan, and here phi is phi tan 45 degree, phi is 0 plus 0. So from here you can calculate C is equal to 11.9 kilonewton per meter cube. You can calculate, sorry, the coefficient is not meter cube, sorry, it is Newton per meter square. Okay. Okay. Now from here we found the coefficient value. So can we consider this as the coefficient value? Yeah, you can consider, but in the problem there is another more given data, that they have done a plate load test was conducted with 30 centimeter square plate placed at a depth of 1 meter with a ground level. So why they have given this data if you can coefficient directly found out using value given up to this place, up to this point? Because they want us to find the another cohesive value also and compare which coefficient value is greater or smaller. Whatever the coefficient value which will be the least, we consider that one. Okay, so that's what the numerical want us to do. So they want us to find C coefficient. Okay, so here the plate load test was conducted at 30 centimeter square plate. So you can apply 30 centimeter square plate, so you can apply this particular formula here of ultimate load for a square footing. Okay, and here you can apply QU here, ultimate stress. Is there given an ultimate stress in this for when the conductor is in? Yes, the ultimate load is given as 13.5 kilonewton. Okay, 13.5 kilonewton. So 13.5, 13, so we will write the formula first. Ultimate stress for square plate is given as 1.3 CNC plus gamma df cube plus gamma v and gamma, sorry, into 0.4 gamma v and gamma. Like this we have to find. The ultimate load can be written as, ultimate stress can be written by ultimate load by area of plate, since it is a square plate, is written as 30 centimeter square plate, so we can consider as 0.3 into 0.3 meter square, correct? And the ultimate load PU in the problem which they got while performing this test is given as, how much it is given as? 13.5 kilonewton. So we get everything directly, 13.5 kilonewton. So QU is nothing but PU by area, that is 13.5 divided by 0.3 into 0.3 will be equal to 1.3 times C, NC, for again this is the same soil where phi is equal to 0, therefore NC is equal to 5.7, NQ will be equal to 1 and N gamma will be equal to 0. So we can write NC is equal to 5.7 plus gamma. So what will be the gamma here also? It will be same bulk density, that is 17. Okay, what is the depth of foundation? At what depth they have conducted the plate load test? At a depth of 1 meter below the ground level. At 1 meter below the ground level, they have said that. Okay, so 17 into 1 meter into NQ1 plus this whole term becomes, due to the NR n gamma equal to 0, this whole term is 0. So from this we can find the second coefficient value C. It comes out to be 17.95 kilonewton per meter square. So earlier we found that comes out from the height of from the critical height HC, we got 11.9. okay, and now we got 17.95 or 11.9. so from this we will consider the minimum C. We will consider the minimum C as equal to 11.9 kilonewton per meter square. Okay, now we can calculate the ultimate bearing capacity QU for strip footing. It is given as C NC plus gamma df NQ plus 0.5 gamma B n gamma. So coefficient is 11.9, NC is 5.7 plus 17. Now here depth of foundation is 1.5. Depth of foundation is 1.5, NQ is 1. Again n gamma becomes 0, so it finishes here only. So from it we get QU as 93.33 kilonewton per meter square. As soon as you get QU, you can find from this, you can find Q net ultimate is equal to QU minus gamma df is nothing but 93.33 minus gamma, that is 17 into 1.5. it comes out to be 67, sorry, it comes out to be 67.83 kilonewton per meter square. And from net ultimate we can find Q net safe is nothing but 67.83 by factor of safety, and factor of safety in the problem is given as 3. 67.83 by 3, and it comes out to be, final answer comes out to be 22.61 kilonewton per meter square, and this is your final answer. So this way you find the net safe bearing capacity for a strip footing by finding coefficient value twice. Thank you for watching.